There's a couple of things that can happen when you are working with non-right triangles. What do we mean by non-right? Does not have a right triangle or a right angle in it. Everything that we've worked with so far with sines, cosines, and tangents, there was always a right angle. Correct? And like the sine was the opposite over the hypotenuse, cosine was adjacent over hypotenuse, tangent was opposite over adjacent, right? Okay? Well, what happens if I have a triangle that is not a right triangle? Similar to this one. Do you see a right angle any place in there?
No.
Okay? I'm going to label them, which means this is side B, this is side C, this is side A. There's a unique thing that happens whenever you have a non-right triangle, and it's called the law of sines. There is a relationship between an angle and the side opposite. That ratio will be equal for every angle. Meaning, side A over the sine of A will equal the ratio of B over the sine of B, will also equal C over the sine of C. Okay?
The other way upside down, so you get it the way the book has it.
Yeah, the book has it this way. Which way you use it, I don't care. Alright? You can either put the angle over the side or the side over the angle. The ratios are still going to end up being equal to each other. Does that make sense? Like if this ratio was 3 over 5, 3 over 5, 3 over 5, then, and this one's 5 over 3, 5 over 3, 5 over 3, if I'm using it for calculating, it's not going to make any difference. So either one of these are true. Some people like this one, some people like this one. I don't care. I prefer this one. But I don't care. Does that make sense? So if I have this triangle that's up here, we're going to call this X, this Y, and this Z. And this angle is 25 degrees. I know this side is 10. And I know this side has an angle of 35 degrees. Can I find Y?
Yes.
Absolutely. By setting up the following ratio. 10 over the sine of 25 degrees would have to equal Y over the sine of 35 degrees. Okay? Well, if I finish solving this, what's the sine of 25 degrees?
0.4225. Yeah.
What's the sine of 35 degrees?
0.5736.
So now that I've put all the numbers in for the items that I know, How can I solve for y? I'd probably do cross multiplication, which means that I would have to take 10 times 0.5736 equals 0.4226 times y.
5.73.
Which means that I'd have 736 equals 0.4226y. If I multiplied the 10. So if I then divided what I have for y, 13 point what?
5.3.
Okay?
You look down to the bottom.
I get carried away with my erasing. Does the cross multiplication make sense?
And then I can go back up.
We okay? All right. We're going to try this triangle. None of these are drawn to scale. So don't go, oh, that's not right. Using law of sines, can I find x? How?
8 over the sine of 78. X over the sine of 60.
Or if you wrote it as sine of 78 over 8 equals sine of 60 over x, you will come up with exactly the same answer, because when you cross multiply, you're still multiplying the same parts together. Okay? Anybody have the sine of 78? 0.9789. Is that what you said?
0.9789.
Sine of 60 is either 0.866 or 1/2.
0.866.
So what do I multiply together?
8 and 8.66, which is 6.928.
I'm sorry, I was writing. You said it was
6.928.
6.928. 0.9781x. Are we okay with that? How do I find x then?
7.083.
7.803.
0.83.
So using law of sines isn't very difficult, is it? In this same problem, what if I was told to find y?
do the exact same thing pretty much.
Okay? The first thing would be is, I need to find the other angle, don't I?
180 equals 78 plus 60.
42.
So you're saying this angle should be 42?
Yeah.
Okay? So if I'm finding Y, by giving two angles and a side, do I even have to worry about the X?
No.
Okay? Can I erase the blue one?
Yeah.
So now that I want to find Y, I had to find this angle, which we know in a triangle, they all add up to 180 degrees, don't they? Okay? How would I set up finding Y then?
Yeah, over the side of 78, so Y over the side of 42.
Okay? What was the sign of 78? I know it was there before, but it's been erased. Is that what you said? It's a sign of 42.
0.669.
6691.
Quick.
5.470. So this was 5.472. What was the blue one?
7.083.
Now I need to ask myself, are these answers reasonable for the angles that are there? Because we have talked about triangles and angle and side relationships.
Yes, they are.
Okay? The shortest side should be opposite the 42 degrees, is it?
Yeah.
The 61 should be the middle, so is 7 in between the short and the long. And the 8 should be the longest side because it's opposite the biggest angle, right? Okay? That's law of science. So right now, what I would like for you to do